run through a couple of examples of some proofs, some coordinate proofs, but not ones that involve slope, because we did an awful lot of them with slope, and now I have a lot of students who seem to think that everything requires slope. So I'm going to start with this number 10. This is not an assignment that you have, so I recommend just taking out a sheet of paper and jotting this down somewhere. We're going to take this figure, and we want to prove that this is a kite. Okay? So when you're starting a proof, what I want you to think about is what you're trying to prove. I want to prove that something is a kite. Well, what does it mean for something to be a kite? The definition of kite is a quadrilateral with two sets of consecutive congruent sides. So somehow in my proof, this is what I need to show, that my quadrilateral has two sets of congruent sides. Okay? Slope is not going to help me with that. But to show congruence, I want to show that their distances are the same. So I want to find the length of all four of these sides and then say, hey, look, these two are congruent and these two are congruent, so this must be a kite. Okay? And I'm actually going to start by writing out the coordinates for these points for two reasons. First of all, you guys tend to see these proofs more often with coordinates rather than the picture being drawn for you. A lot of the times it'll just say, show that the figure with these coordinates is a kite. So I want to work from the coordinates, not from the picture. And also that way you don't have to spend a lot of time redrawing this picture. So kind of just sketch this figure on your paper. And then the coordinates of H are 0, 4. Coordinates of J are 4, 0. Coordinates of G are negative 4, 0. And the coordinates of K are 0, 2. Okay, so I'm going to start, and this might get a little jumbled because I'm a little short on space here, but I'm going to start by finding the length of GH. Okay, so I'm finding this length here. And remember, length is really just the Pythagorean theorem. Okay, so I want to sort of form this triangle here and here and turn this into a right triangle so that GH, what I'm looking for, is the hypotenuse. And I know that that's on a grid, so you can just count the boxes. But if you didn't know to do that, here's what you can do. Take your endpoints of G and H and subtract them. So negative 4 minus 0, so I'm subtracting my x's, is negative 4. And 0 minus 4 is also negative 4. Now, that's just like what you do when you find slope, except I'm not going to make this a fraction. I'm not going to say, oh, look, it's negative 4 over negative 4. I'm going to plug those numbers into the Pythagorean theorem. Okay? When I plug them in, though, I'm going to ditch the negatives. And the reason is what these represent are distances. Okay? So that negative 4 really means that there's 4 spaces between H and G horizontally. It means this length is 4 spaces. And you can't have a length that's negative. So if you do this and something comes out negative, just ignore it and make it positive. However, that only works for distance. So now I'm going to take these two and I'm going to do 4 squared plus 4 squared equals c squared. Well, 4 squared plus 4 squared is 32 equals c squared. And then I'm going to take a square root and a square root. Oh, let's see. It's going to be 5 point something. Yep, 5.66. And that 5.66 is my length of GH. Okay? Now let's do the same thing with JH. Okay, so now I'm looking at this guy over here. So JH, I'm going to do the same thing, subtract the x's, subtract the y's. So now I'm looking at, here's J and here's H. So 4 minus 0 is 4. And 0 minus 4 is negative 4. But when I'm talking length, I really just care about that being a 4. So I'm going to take those two things, do Pythagorean theorem, and do you see that it comes out looking exactly the same like the one above? So I don't care if you redo this calculation or not. As soon as you get this set up and it looks exactly the same, you can now say, all right, I know that's going to come out to be the same answer. So 5.66 is equal to JH as well. So now based on these two things, I can make the statement JH must be congruent to GH. That's what I just showed, is that these two sides are congruent. Okay, that's sort of half my battle. Okay, so I showed that those two are congruent to each other. All right, I'm going to do the same thing with the other two sides, and this might start to get jumbled here, but let's go GK. Let's go this one. And remember, I'm going to subtract the x's, subtract the y's, which is really just building my triangle for me. So GK would be, let's see, here's G and here's K. So negative 4 minus 0 is negative 4, which I'm going to treat as just a 4. And for my y's, 0 minus 2 is negative 2, which I'm going to treat like a 2. Because when I build this triangle, it's hard to see, but the length of this side would be 2 and the length of this side would be 4. That's where these numbers come in. Okay, so I'm going to take these two, plug them into Pythag. 4 squared plus 2 squared equals c squared. That's 16 and 4, so that's 20 equals c squared. Take a square root, and I get 4.47. And that's my length of GK. Okay. Now let's do the same thing with JK. So over here I'm going to do JK, which would be the 4, 0 and the 0, 2. So 4 minus 0 is 4. 0 minus 2 is 2 that I'm going to pretend is really a negative 2. Nope, sorry. It's negative 2 that I'm going to pretend is a regular 2. Got a little ahead of myself there. Same thing, set up Pythag. 4 squared plus 2 squared equals c squared. Okay. Looks exactly the same as this one, so I know it's going to come out to be a square root of 20. Therefore, I can say 4.47 is the length of JK also. And from these two pieces of information now, I can say that GK has to be congruent to JK. So now I've got JH and GH congruent and GK and JK congruent. This would obviously look a lot nicer if I was writing it all out top to bottom. You know, I'm kind of just trying to squeeze it in the space that I have. But so based on these two statements, now I have enough to say that this is a kite, because that's what a kite has to have, is two sets of consecutive congruent sides. So then I could say, this would be sort of my conclusion statement over here, GHJK is a kite by definition of kite. Okay, and that's what these two things gave you, is that definition of kite. Notice that this conclusion statement is always starting with what you were trying to prove. This told us to prove GHJK is a kite, so I started out by stating, hey look, now GHJK is a kite. Okay, so that's how I would tackle that one. In the next video, we're going to tackle a proof that has to do with circles.